Hello, everybody, and welcome back to another installment of Microeconomics. We are wrapping up our discussion of taxes here today. Really going to talk about the anti-tax today, a subsidy, which we're going to literally model as a negative tax. So this is, I believe, the fourth part of the installment, and we're going to just pick up more or less right where we left off. Or a little bit of review here. Recall that a constant per unit tax drove a wedge between the price that buyers paid and the price that sellers received for a good. And it did so in a way where the buyers actually wound up paying more than the sellers were getting. That difference, again, was accounted for by what the government was taking as its cut of the quote-unquote economic pie. A subsidy, and we're going to consider a constant subsidy per unit, very similar to a tax, in that it also drives a wedge between the prices the buyers pay and the sellers receive. But the wedge is a little bit different. Okay, in this particular case of a subsidy, note that the sellers are actually getting more than what the buyers are paying, and the government is pitching in to account for the difference. The government's not collecting a piece of pie in this case, it's actually putting one back in. Because of that, we're going to treat the revenue associated with the subsidy much like negative tax revenue. It's going to be a negative piece of economic pie, right? When the government raised tax revenue, that revenue is going towards providing things like public goods and services. However, when the government provides a subsidy, that is taking away funds that would be going towards those purposes. So again, we're going to treat the revenue like a negative piece of economic pie. I want to basically jump back to the analytical example we looked at with the tax, and we started with the demand curve equation and a supply curve equation. And in our previous videos, we looked at an example where we levied a $10 per unit tax. And again, remember, it didn't really matter who we actually levied the tax on, buyers or sellers. It was actually the relative elasticities that determined who felt the incidence of the tax burden. Okay, today we're just going to do a small switch here. Instead of tax, now we're dealing with subsidy. Okay, and similar to the tax, it doesn't really matter who we physically give the subsidy to, whether it's the buyer or the seller. Both feel some incidence of the subsidy, and again, that is related to the relative elasticities of supply and demand. Now, in order for us to describe the tax wedge, we had this equation that suggested that the difference between the price that the buyer was paying and the price that the seller was receiving was accounted for by the $10 tax. Now, all I'm going to do is I'm going to switch out the tax for a subsidy. So all the words where you see tax, I'm going to switch into subsidy. Okay, and I argued earlier that a tax is literally a negative subsidy, or vice versa. A subsidy is a negative tax. So when I make the following change, it should not surprise you. Okay, we're now, instead of the tax, which was $10, I've input a negative subsidy of negative $10. So it's like we have a negative tax now. And you'll notice if I rearrange that equation, if I multiply through by -1, for example, okay, then we can describe the subsidy wedge in similar fashion as we had it on that first introductory slide, where the difference between PS less PB has to equal positive $10. Okay, now we want to find the volume of trade under the subsidy, so we're going to plug in the supply and demand curves very similarly to how we had done this before. Okay, the equation for the supply curve was PS equals Q. The equation for the demand curve was PB equals 100 minus Q. So I plug those in, add the 2Q over, add the 100 over to the right, divide by 2, and you should find that the quantity of trade under the subsidy increases to a volume of 55 units. Now, note that the equilibrium quantity, which we saw for in a previous video, was only 50 units here. So the subsidy is encouraging a few trades that otherwise would not have taken place in equilibrium. Specifically, that subsidy, I'm going to argue, is encouraging bad trades, trades that would reduce the total surplus. In other words, trades that wouldn't have been mutually beneficial at the current market conditions. Okay, so if I plug that 55 units of trade back into the demand and supply curves respectively, we can figure out the price that the buyers are paying here, 45 bucks. The sellers are receiving 55, and the reason the sellers are able to get more than what the buyers pay, again, is because the government is throwing in the difference. The government's accounting for that $10 difference. Okay, so to summarize, okay, the competitive market model, note that it made the following prediction regarding the volume of trade in a market under the varying policies. That quantity is restricted below equilibrium under a tax. It's pushed above equilibrium under a subsidy. In fact, a subsidy is the only type of price control we've looked at so far. Okay, price floors, ceilings, taxes, and subsidies. Subsidy is the only one that has caused the volume of trade to increase above equilibrium, meaning it's the only policy out of those four that I just mentioned that is causing a deadweight loss because it is facilitating bad trades. Okay, the taxes, they reduce the volume of trade relative to equilibrium because they were blocking good trades. Subsidy was doing the opposite. Okay, again, both policies induce deadweight loss in the competitive market model. The taxes from preventing good trades and the subsidies from fostering bad ones, ones that reduced surplus. Okay, again, who actually pays the tax or the subsidy didn't actually determine the incidence of the tax or the subsidy. This was determined by the relative elasticities of supply and demand. The relative slopes of the demand and supply curves determined to what extent either market agent, the buyer or seller, was helped or hurt by either of these policies. Okay, I want to take a minute and just go through some surplus analysis here. Okay, so I got some supply demand curves. I've labeled some areas. First, just note that if we were to pay the buyers a subsidy, well, remember when we charged the buyers a tax, it lowered their willingness to pay because we were forcing a tax on them. The opposite happens when we subsidize them. Okay, when we subsidize a buyer, this is going to increase how much a buyer can afford to be willing to pay at max for a good because the government is now giving the buyer some additional amount of money, S dollars per unit in this example. And again, we model this as shifting the demand curve straight up. Okay, similarly, we could have given the subsidy to the seller. And in effect, if we were to give the subsidy to the seller, this would reduce the seller's marginal production costs. Recalling that the supply curve measures the seller's marginal cost. Remember that the tax increased the marginal cost per unit from the seller's perspective. However, the subsidy is going to do the opposite. Okay, the government is now paying a part of the production cost. So just like the subsidy increased the demand curve for the buyer, it is going to shift the supply curve for the seller straight down. Okay, note again that it didn't really matter who we gave the subsidy to. We could have given it to the buyers, like we did on the right, shifting the demand curve up, or we could give it to the sellers like we did in the left picture, shifting the supply curve down. In both cases, the quantity of trade is the same, Q sub. In both cases, the price the sellers receive and the price the buyers pay are identical. Okay, so we saw the same exact thing in the case of a tax. This is just a negative tax, so it shouldn't be any surprise that this is any different. So again, the key here is that similar to a tax, it didn't matter who we levied a subsidy on. If we paid it to the buyers or sellers, the market outcome was the same in that the subsidy put a wedge between the prices that these agents were paying and receiving. Okay, so rather than, again, worrying about who's receiving it, which curves do I shift, we don't need to do that at all. We need to take the size of the subsidy and we need to move it in between the supply and the demand curve, but this side from the right to put that wedge in there to figure out the volume of trade as we had just done mathematically in the last numerical example. Okay, what I would like to do next is just do a little bit of surplus analysis. Let's count for the consumer and producer surpluses, their pieces of the economic pie. We'll account for the government's piece, which in the case of a subsidy winds up being negative since it costs the government revenue to generate the subsidy. And we're going to see here that in doing the surplus accounting, the surplus looks a little weird in that there's an overlap of the consumer and producer surpluses, but that will go away once we account for the revenue, which again, we're treating like a negative piece of pie. All right, so first off, you should be familiar with what the total surplus situation looks like with no surplus. Consumers are getting AB, producers are getting CD. Total surplus is that region A, B, C, D. Okay, however, if we were to subsidize this market so that the buyers are now paying PB, which is slightly lower than P star, note that if we measure the consumer surplus relative to PB, now the consumer surplus has actually gone up a little bit. It's the area above PB, below the demand curve, all to the left of Q sub, which is A, B, C, E, and F. So it looks like here with the subsidy, the consumers gain C, E, and F. So they're better off. Okay, similarly, the producers. Okay, well, the price that they get has now risen above P star. So the producers, oddly enough, are also better off here. Again, the producer surplus is the area below PS, above the supply curve, to the left of Q sub, and this is the area BCDH. Note that if we add the producer and the consumer surplus together, that we've counted areas B and C each 2 times. Okay, this can happen. It's not an illegal maneuver for us. We're just going to remember that we've counted B and C 2 times because there is a part that we have not yet dealt with of the economic pie, and that is the negative piece that the government is putting into the market. So we're not going to forget about the subsidy revenue. Recall that unlike the tax, which is generating positive benefits for society, the revenue from the subsidy is taking away from that. And the amount it costs the government is just the size of the subsidy S times the number of units, which is Q with the SUB subscript on it. Okay, so that whole pink region there, B, C, H, E, F, G, that is the amount of money it costs the government to cause this improvement in each the producer and the consumer's economic pot. Okay, the problem is what we're going to see here, that the gain to both the buyers and the sellers is not larger than what this costs the government, than what this whole pink area is. So all we're going to do is subtract out all of these pink triangles from the previous total surplus pie picture. Let me just jump back to it very quickly. Okay, we're going to subtract out the revenue box B, C, H, E, F, G from this picture. Okay, when we do that, we're going to take away 1B and 1C, but then we'll have 1B and 1C left because we have counted B and C each twice. Note that H, E, and F, we've only counted once, so when I subtract those out, they will go away. They will not be there anymore. G, however, we hadn't counted at all. That wasn't a piece of either person's pie, but it is a piece of this negative revenue pie, meaning when we subtract G out, G actually is a net loss to society. Okay, so once we account for the total surplus with this negative revenue piece in here, you can see that the total surplus now is A, B, C, D minus that area G. So it has indeed shrunk relative to the size of the total surplus pie in the market equilibrium at Q star. Okay, so we see some deadweight loss here. Again, the source of the deadweight loss comes from too much trade in this market relative to the equilibrium quantity, relative to what was efficient. All the units traded between Q star and Q sub are done so where the cost to the seller exceeds the value to the buyer, meaning if you put those two individuals in a room together, they would not be able to form a mutually beneficial trade, and they shouldn't have traded. Okay, so the subsidy is providing a climate whereby it is encouraging some people to trade where otherwise they would not have on their own.